Ever needed to expose Python functions as network tools without writing API boilerplate or managing serialization? We'll build a FastMCP server that automatically converts a simple greeting function into a production-ready HTTP endpoint, complete with type validation and streamable HTTP protocol support. You'll see how the same declarative code can run locally via STDIO as a standalone HTTP service, or even deployed to FastMCP Cloud, all while keeping the core logic unchanged. From FastMCP, import FastMCP. MCP equals FastMCP, my server. At MCP, tool. Def hello name, SDR. Return fhello, name. If name equals main. Hash start an HTTP server on port 8000. MCP, run transport equals HTTP, host equals 127.0.0.1, port equals 8000. This demonstrates the declarative RPC pattern for building protocol-agnostic services. The code shows how Python functions become network-accessible tools through decorators, where at MCP tool transforms type-annotated functions into auto-discoverable endpoints, while the framework handles serialization, validation, and transport concerns. The distinctive aspect is the complete decoupling of business logic from deployment details, enabling the same code to run locally via STDIO or remotely via HTTP with minimal configuration changes. The pattern works through a two-phase process: declaration and execution. During declaration, decorators capture function signatures and type hints to generate API schemas, while the execution phase uses the selected transport, STDIO by default or streamable HTTP for network access, to handle message framing and protocol specifics. The framework provides multiple deployment options: direct script execution with MCP, run, ASGI integration via MCP, HTTP app for production, or FastMCP CLI for development, while maintaining a consistent programming model where tools are just Python functions. This approach eliminates traditional RPC boilerplate while adding deployment flexibility. You avoid manual route handling, payload parsing, and protocol implementation, yet can customize endpoints via MCP. Run path equals /custom, or add non-MCP routes with @MCP, custom route. The same codebase can deploy to local processes, HTTP servers, or FastMCP Cloud, making it ideal for AI integrations, microservices, or any scenario requiring rapid protocol-agnostic service development. The trade-off is framework dependency, but the productivity gains in reduced boilerplate and deployment flexibility typically justify this for tool-oriented architectures. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for building AI-callable tool servers. It enables a declarative RPC pattern where Python functions become typed, network-accessible endpoints with automatic schema generation from type hints and docstrings. The framework handles serialization, validation, and transport abstraction, defaulting to STDIO, with HTTP using streamable protocol. The same code can deploy to FastMCP Cloud or self-hosted servers, with production deployments typically using the ASGI application approach via MCP, HTTP app. MCP equals FastMCP, my server. Instantiates the FastMCP server with my server as its namespace identifier. This server instance becomes the central registry for all AI-callable tools, handling automatic schema generation from type hints, request validation, and protocol serialization. The same instance can be deployed locally via ASGI using MCP, HTTP app, through the FastMCP CLI, or to FastMCP Cloud with minimal configuration changes. At MCP, tool. Def hello name,
SDR.
The @MCP tool decorator exposes this Python function as a remote callable tool in FastMCP's declarative RPC system. It auto-generates open API-compatible schemas from type hints while handling serialization, validation, and protocol translation, eliminating manual endpoint boilerplate. The same decorated function works across transports, STDIO default, HTTP via transport equals HTTP, can be deployed to FastMCP Cloud unchanged, and integrates into ASGI apps via MCP, HTTP app for production use.
Return f-hello, name.
This f-string constructs the tool's response by interpolating the validated name parameter into the greeting template. The return value becomes the serialized payload sent back to the caller, with FastMCP automatically handling both JSON serialization and protocol framing. This pattern keeps business logic clean while the framework manages transport concerns like streamable HTTP or STDIO protocols.
If name equals main.
Python's entry point guard prevents accidental server startup when this module is imported, ensuring the HTTP server only launches during direct script execution. The guard enables safe modular reuse while maintaining explicit control over server initialization.
Hash start an HTTP server on port 8000. MCP, run transport equals HTTP, host equals 127.0.0.1, port equals 8000.
Launches the FastMCP server using HTTP transport on 127.0.0.1.8000, with the endpoint path defaulting to /MCP unless overridden via the path parameter. This uses FastMCP's declarative RPC pattern, where decorated functions auto-expose as API endpoints with built-in validation and streamable HTTP protocol support. For production, you'd typically use MCP, HTTP app, to integrate with ASGI servers like Uvicorn or deploy via the FastMCP CLI. The same code can also target FastMCP Cloud with minimal changes and supports custom routes via @MCP, custom route for non-MCP endpoints. FastMCP HTTP transport pattern. The @MCP tool decorator and HTTP transport transform Python functions into network-accessible RPC endpoints using streamable HTTP protocol, with automatic schema generation, validation, and bidirectional streaming capabilities. Custom endpoint paths require explicit configuration via MCP, run path equals /custom, and production deployments should use the ASGI application approach with MCP, HTTP app, for full server control.
The decorator that names the tool erases the need to name the root.